So now here one point what people will ask us is what is the image? So image is a blueprint or template kind of thing. In the just like AMI we have the OS image, but this is at the container level image we have, which like how to start the application. We required code, libraries, dependencies, environment variables, all the configuration details, all have been stored in a single file called as image. So with this, what is the advantage is like if that image is there, anyone can easily can deploy those containers or application deployment also very easy to deploy those applications. Okay, so that is the main advantage of using the images. So we have the images mostly we are downloading from. Okay, so by default there would be a lot of images. Say images we are getting
Docker Hub.
from the Docker Hub. If you want to create your own customized images, okay, so we need to use Docker file. Okay, using the Docker file, we can create our own images also. Otherwise, even we can use one command called as Docker commit. That means from the container also we can create the image. Okay, so we can create the image like that. So what is the meaning of Docker Hub?
It is a registry for
Registry
Docker.
where all the images we can store. Okay, so from there we are going to download the images. And what is the meaning of Docker file is?
It is a build file for Docker
Yeah, in
images.
order to build our own customized images with our own instructions, we are going to use the Docker file. Okay, so then like what is the meaning of Docker commit is even we can create an image itself, but from the container we can create an image. So mostly among these, which one we are going to use in the real time?
Docker file.
Yeah, Docker file. Okay. We can use the Docker file is the more DevOps wise also we have lot of advantages. If you have the 20 microservices for your applications, we want 20 Docker images because each image will have their own configurations, their own dependencies, their own application code. So like this, we need to create the different images we need to create. If it is the base image, directly we can download from the Docker Hub. And here there is an example. What is that meaning of Nginx colon latest means? What is that latest is?
Latest version of that
Yeah,
application.
if you don't specify also, that would be the latest version itself, or we can download the latest version. We can download. Okay, then the running state of the container or running instance of the image is called as the container. And in order to run the container, we require the CPU, memory, all those required. That's hosting infrastructure is going to be provided. Okay, but it's not the complete VM. It's a very lightweight, isolated environment we are going to get. Okay, so whereas the nature is dynamic, it's we can start, stop, move, or delete it also. We can do it. Say here, the running state of that image is called as like a image. Sorry, running state of the image is called as a container, and from the single image we can run the multiple containers also. Okay, whereas the template or blueprint is the image, or it's maybe a file instructions also we have. Then like container is the running instance of the image, whereas it's the dynamic also. And to create the containers, we are using the image, and containers to run the applications, we are running those containers. Okay, so then in the Docker lifecycle, what are the Docker lifecycle we have, we'll discuss. So we can pull the image. So that means when we like a pull, before pull, what we can do is we can search also. Okay, so search also is going to search all those images. Otherwise, we can build also from the Docker file. This is building an image also, or we can do the Docker commit also. Then what is Docker images is showing is whatever the images locally we have all that we are going to show. And here we have RMI. Any idea what is the difference between RM and RMI? What is the difference between RM and RMI? RM is
To delete the containers.
To delete the stopped containers. To delete the stopped
Stop.
containers. RMI is
To delete images.
delete the image from the locally. To delete the image from the locally. Okay, then first we are going to pull that image. After we pull the image, either we can create, but directly like a run is doing two operations. What is that is? It's creating and
And
starting also. So now we can use here Docker create command we can use, but not required because in the Docker run itself it's performing two things. Okay, even three things also sometimes if done, it's going to search the image locally. If that image is not there, it's going to pull that image also. From where it's going to pull that image?
Docker Hub.
Docker hub. Okay, so now here Docker run hyphen name. My Nginx is the name of the container. Hyphen D is detach mode. Hyphen P is publish port. Then 8080 is from the outside and 80 is the internal and Nginx colon latest is the
Image.
image. Okay, so then like run is performing two operations. It's create. What is the difference between create and run? So create is creating a container, but it would be in the stopped state. But run is doing both the things. It's creating plus
And
starting also. It's creating and starting also. Otherwise, again, you need to do Docker start that container name or container ID. How we can get that container IDs? Okay, so now here Docker PS if we use PS will show all the containers. Okay, then here what is the difference between PS hyphen A and PS? PS only shows the running containers only, whereas PS hyphen A will show the
all
all
contain
stopped containers, all those like it shows. So PS only shows the running containers and PS hyphen A shows all the containers it shows. Then there it gets the IDs also. Just like for every instance we have an instance ID, right? So now here we are also getting that. Then Docker start that my Nginx we can give, or instead of that container name what we can give?
container ID.
A container ID we can give, or we can stop the container also, then restart the container also. These all we have done at the instance level, right? Start, stop, restart, terminate, all that also. And we can pass the container. Okay, and very, very important. So view all the running containers, view all containers, even stopped state also ps hyphen a. And all the images we can see by through which command?
Or images.
Yeah, Docker images. So Docker images, we can see all the images we can see. Okay. So then one important command is there, inspect. Say inspect will show more details on that. Okay, it shows more details on that, like maybe container or image level. We can get it like more details like regarding that container or image networking. Okay, so that if we want more details regarding that, we can get it from
Inspect.
inspect. So now even in the Kubernetes also we have same command. Describe is that here we are using inspect. Okay, so then exec, like by default, whatever that we are running on the Linux bash, it is running. But if you use the Docker exec kind of command, that command is running inside the running container. We'll discuss more on the exe part also. And attached to a container, like maybe we can attach to any of the networking kind of things. Those all we can attach to the container also. We can attach, then we can kill the container also. Okay, then we can stop, and prune will do all unused containers, all that it will remove. So prune is removing, all stopped containers is removing. Okay, so now in the life cycle we can create, start or run, pass, unpass, stop, restart, kill, Finally, we can terminate by using RM. But RM will remove only
containers.
running containers. Then we need to use -F option. Forcefully we can remove. Okay. So then, like some of the basic other Docker commands also we'll discuss. Docker hyphen version. So Docker hyphen version shows which version of the Docker engine or Docker daemon we are using. As of now, this is like a 27.0.2. In that again, we'll have the minor build versions, all those we have. And all the information regarding this Docker, we can get it through Docker info. Docker info. That means first command run the Docker version, then check the Docker info, and the third command try to run Docker run hello world. Hello world is also basic kind of command from the Docker. What is that command? What is that container will do is at that image, it download that hello world image from the Docker hub and run that container. Will print that what are the steps it perform, and it will be exited. If you run this command successfully, what is that meaning is your Docker environment is working fine. For the testing purpose, we are going to use this Docker run hello world. Then we can see all the images by using Docker images, and we can pull the images from the Docker pull command. And if you want to search from the registry, Docker search. And here this is very important from the interviews. Even in the next sessions, we'll discuss what Docker build will do is going to build an image from the Docker file. Okay, and if we want to remove the image, we need to use Docker RMI. We need to use Docker RMI. We need to use, okay, and to create a container and start that container, like we can use Docker run -IT interactive mode, and we'll discuss what is that interactive mode also. And here this would be in the detached mode, it is running. Okay, so what is that interactive mode also we'll discuss, but mostly in the production we are using in the detached mode itself, it will be running in the background. And here it's going to use the port numbers we are using. So now here we are going to use 8080:80 from the host side, uh, 8080, and it's going to be like internally it's going to redirect to 80 inside the container, 80. Okay, then like we can do the start, stop, restart, kill, RM. Then very important is Docker logs that container name, or we can give the container ID also. What it shows is, say it shows the inside the container we no need to go. Say here what is that is, say suppose if we have any issue, I need to check the logs. So those we can check it by Docker logs that container name, or like for the troubleshooting purpose, this logging is important. But in the real time, we may have some thousands of containers. Those containers we can't check the logs individually from the container level. We required a centralized logging. So that's the reason we have ELK stack or APM kind of tools we are using. What is the meaning of centralized logging is, for each and every container, I don't go and I don't verify. I want to check it from the single point of location. I want to get that. Okay, so that is the main advantage. We are going to get that. Okay, so that's we need to use Docker logs. Okay, so then here we have Docker inspect also we have. More details we can, even for troubleshooting purpose also we are going to use. And what are the running process, resources, all those also we can get it by Docker top. Just like in the Linux mission, we have the top command, but this is at the container level, it is going to show that. At the container level, it is going to show that what is the running process and how much CPU memory used by that container also we can get that. And to execute the commands or to enter insights, we are using, this is also very important command, docker exec -it. That web server is nothing but here the container name, then bin bash, like this we are going to enter. And volumes I will explain, networks also I will explain, and docker container prune. So prune will remove all the like a cleanup kind of activities it will perform. That means I want to remove, I have lot of unused containers are there or stopped containers are there. Then I can use Docker container prune I can use. And if you want to remove all the images, then Docker image prune I need to do. And unused volumes, if I have Docker volume prune, I need to do it. Okay, then I want to remove everything. Say instead of creating, deleting those cleanup activities, single shot I want to clean up those. Then I'm going to use Docker system prune -a. Okay, so that means all are getting deleted. Okay, all are getting deleted. Okay, then Docker system level, what is this like how much space? Because on the host itself, what is the space we have? That CPU, memory, disk, all that are used by the container also. Okay, at that moment, like here we are going to check the disk space also. And image management level also, we have some of the commands which are related to Docker tag. Then pushing. So what pull will do? What pull is doing?
Downloading image
Yeah, from the
from Docker
yeah. So what
to
push
local.
will do is after we build the image, we are tagging it, then we are pushing also. Okay. Then I want to instead of pushing to the registry, instead of downloading, for one of my developer or someone, I want to give in the form of tar format. Say that is one of the Linux archive format. Then I can use save option. Okay, so then from that again, if I want to load that image, then I need to use load option. Can you tell me the difference between save and load? What is the difference between save and load?
Save means saving from image to tar.
Yeah, so that's all. After that user copies the tar image. Okay, he need to again need to convert into image, right? For that, what you need to do?
Docker load.
The Docker load. Docker load itself. Okay, so then here this is very important. I said right, we have three methods we can use the images. First one is from the Docker Hub, we can download. We can create from Docker file, but already one container is there. Even if you understand AWS wise also, we can create an instance from AMI, but still we can create an AMI also from the instance also. But now here, what is this Docker commit is doing? Already we have a running container. From that I want to
Create image.
create an image. That image instructions I don't want to keep in a Docker file. Exact container. I want another 100 or 200 kind of things. At that moment, what I can do is at that moment what I can do.
Create an image and create.
I can create an image and I can create multiple containers from that. I can create an image and I can create like multiple containers from that I can create. That is the purpose. This is the third method of creating our own. This is the third method of creating our own
Docker image.
images. Okay, so that is the purpose we are using a Docker commit. Then, like my container is the existing container name, or we can use the container ID also. Then, like that image colon that tag version we need to specify. Image and tag version we need to specify for this. Okay, then we can export the complete container also. I want to store into another. Previously we saved that into image we saved, but now here a running system itself I want to migrate or export. Okay, then I'm going to use Docker export. Later, that's I want to import also. This all will discuss. Then here we want to limit the CPU memory. Say suppose if you go for an EC2 instance, T2.micro, we are getting only one CPU and 1 GB RAM kind of thing. But if we want to give like only limited CPU and memory, okay, so that's we can give limited, here we can use the limited and memory and CPU we are going to give. It's not allocating more than that. Is not going to allocate. Even at the container level also, we can restrict these kind of things on the container level also. Okay, so mount will discuss. And -e, we can pass any environment variables also we can use. And if you want to change the name of the container, we can use a Docker rename. Okay, then logs already we discussed, right? Here F is a follow kind of thing. F is follow kind of thing. With this, what is going to happen is even if any new logs are like writing also, all those changes will come. All those changes will come if I use
Fun F.
say hyphen F. If I don't use the hyphen F at that moment, what are the logs we have, those will get it. But if I use the hyphen F, it's
You get
it's
lock screen.
like it's not force here in this. At the RM and RMI, it's a force. Here it's going to be follow live logs. Okay, and output like we can use that hyphen tail. Last 100 logs we can get that. Okay, and Docker stats like one container level top will show, all the container level Docker stats will show. Okay, then we have a Docker Compose also. So Compose is a like a tool in the Docker where we can create multiple containers, their network storage, all those as a single shot we can create by using Docker Compose. So we'll discuss Docker Compose also. And what is the scanning is we have the image level definitely for the vulnerabilities, all that we need to scan. Okay, so that means here what are the steps we'll do in the real time is, so we are going to do the Docker build. So from the Docker file, an image is going to be builded. Then we need to change that into appropriate name by using the Docker tag, then scan that image, then Docker push. Docker push where we are pushing to the Docker hub, or maybe in the if we are using AWS, we are using ECR or ACR, we are pushing. Okay, so these all the steps we need to perform. Mostly with our pipeline itself, we are going to automate this. With the pipeline itself, we already have the Docker file for the microservices. We are going to build those images, then tag them with appropriate names and the tags, all those. Then scan those images for the vulnerabilities. Okay, so now here we have the command we have using is Docker scan. But even there are some tools also like Trivi, Anchor. Okay, so then what is the difference between Docker scan and say on the pipeline already we have implemented code scanning, right? What is the tool we have used?
Static code analysis, Sonar Cube.
Sonar Cube we have used. Then that is at the code level it's going to perform. Whereas Docker scan is at the image level also we need to perform. We need to perform both the things. At the code level also we need to perform, and the Docker level also we need to perform those scanning. For the code level scanning we use the a Sonar Cube or Sonar Cloud we can use. At the Docker level, in order to use, we have the Docker scan command. This is the internal tool we have. Then we have Trivi is there. Okay, so we are going to use Trivi, and like Anchor also we have. Okay, Docker Scout also we have. So Docker Scout kind of tools also we can use. Okay, so these all the tools we are going to use. Okay, so then after scanning, we can run the full host privilege method also we'll discuss. Okay, so then Docker inspect already we discuss, and in the which format you want to search those also we'll discuss. Now coming to the Docker, so already in the Docker architecture, what are the components we have in the Docker architecture? Sorry, Docker architecture wise, we have Docker CLI, then Docker daemon or engine we have, then Docker registry. Okay, so then Docker is the command line tool. We have Docker command line tool. Okay, so then additional to this, today we discuss about one tool like a Docker file. What is Docker file? Docker file having some instructions. Okay, so from that itself we can create our own customized images we can build by using the Docker file. Our own customized images we can build by using Docker file. Okay, so then what is that Docker compose? What is Docker compose? So Docker compose file. So Docker file is there. Docker compose file also is there. In the Docker compose file, we have all the instructions to create multiple containers, their storage, network. Say if I have 20 microservices, 20 times I no need to run Docker create command or Docker run command. All that we can do the automation level. We can stop, start, all these operations we can perform through.
Docker Compose.
So Docker compose is that command. So Docker compose is the command we can give. Okay, so that is the purpose of using Docker compose. Then here we have Docker volumes, Docker networking also. We'll discuss those Docker uh, Docker volumes and Docker networking we'll discuss. Then another very important we have is Docker cloud also is there. Even we can use some of the cloud services also. Then Docker very important is Docker Swarm. So what is the meaning of Docker Swarm is group of Docker engines as a cluster we are going to get in the Swarm. So Docker Swarm is an orchestration kind of tool from Docker wise, but we have one more leader is there, that is Kubernetes. So if someone asks about the what is the difference between Docker and Kubernetes means both are two different products, but there is a comparison between Docker Swarm versus
Kubernetes.
Docker Swarm versus Kubernetes. We have the differences there. Docker Swarm versus Kubernetes, we have the difference because both are the orchestration kind of tools. And inside the Docker Swarm, we don't create the containers, we'll create Docker services and Docker stacks will create. So what are those services and stacks also? We'll discuss. Okay. So then, like here, what is the Docker file? Your understanding is, so Docker file is having our own instructions. And for each microservice, we have a one Docker file would be there. And from that, we can create like our own images by using the Docker build command. After that, we need to scan them. Then like we need to uh, tag them, push to the registry. And after deployment also, the continuous scanning is mandatory for those. Continuously, we need to monitor those. So then what is Docker file and Docker compose file? Compose file is used to create our own say multiple containers all instead of running multiple commands as a single shot in the compose file we are giving, and using Docker compose up will come up all the containers, down will delete those containers, stop, start, not at the single level, multiple level we can perform by using Docker
Compose.
compose. Then for the persistency, we're adding the Docker volumes. Networking is also, we need to understand that networking also will discuss. So here, what is the Docker volume? So what is the concept of Docker volume is, so assume I have my application logs, application data. I'm going to lose it if my container is in the stopped state or if my container is deleted. Okay, say in the microservices while deploying the application, those containers are very dynamic kind of thing. Some of the containers would be scale up, scale down, some of them deleting, some of them may be stopping, some of them may be exiting. Okay, some of them may be crashing. Then like the data inside the containers by default is not persistent. That means only at the running state itself we are getting the data, but that is not suitable for the production kind of workloads. In order to add that kind of persistency for those containers, we are going to use the volumes. Means by default, the data inside the container is not persistent. Say you have your laptop, if your laptop is shut down or restart again, your data is still persistent or not? You can access your data or not? Yes, we can access our data after like a restart also. But in the container environment, if the container is deleted, we are losing our data. Okay. So in order to by default, can you tell me whether the data is persistent or non-persistent? Inside the container by default.
Non-persistent.
Yeah, it's non-persistent. Then what is the problem? If the container is in the stopped state, we can't access that data. So in order to add the persistency to the volume, to the containers, for the production, it's mandatory. We need that persistency. For that, we are going to add the volumes. Okay, so now here we are going to add the volumes. By adding a volume, like the data is going to be persistent, even if the container is deleted or stopped, hanged, crashed, the data is going to be persistent. Okay, even if the container is deleted also, by default, the behavior, one of the challenges, by default, the data is going to be lost. That's the reason for the production data, it's mandatory. We need to attach the volumes. And even in the Kubernetes also, we have persistent volumes and the PVC we have. Okay, so persistent volumes and the persistent volume claims we have. Okay, so now like why we need the volumes is data is persistent, and one more advantage of the volumes are I have one data that I want to share with the multiple containers. That is also suppose same data I want to copy to 100 locations. I no need to keep that. I'm keeping that in one location itself. Like that can be shared by multiple containers also. Okay, then like even volumes or performance also is going to be and easy to take the backups also. Okay, so here in the volumes also like we have three types of volumes we can support it in the Docker. Okay, the first one is Docker volumes is one method. Second one is bind mount is second method. Third one is TMPFS. So among these three, always is recommended to use Docker volumes itself. Even compared to bind mounts, TMPFS volumes are secure and performance wise also. And Docker volumes are going to be stored in the Docker space itself. Okay, so that's like by default we have like a three types. Automatically when we use without having a name also we can use, but that's not a best practice. Okay, so then here we are creating our own volume. So what is the command we use here? Docker volume, create my data. But even if you don't create a volume and if you attach to the container, automatically that volume would be created. So now try to understand here. Uh, Docker run -d -v we are attaching. Then my data is the volume name. Then :/data Ubuntu. Whatever that inside the Ubuntu /data is our destination and my data is the volume. Okay, so like this here, and if I create a volume, that volume is going to be created in var lib
Docker.
docker volumes. See here we have the volume name. In our scenario, what is the volume name? Say in that again underscore data is the that in that the data is going to be whatever the data we have stored inside the Ubuntu container. The data is going to be stored in the my data volume. By default, the data path is var lib docker volumes. If it is Windows, it's just like maybe C drive program data like that. Inside that we have the docker. In that it's going to store. Okay, and for every volume, like in our scenario, the volume name is my data is our volume name. Inside that underscore data, the data is going to be stored. Even if that container, like whatever the container is deleted also, we don't have any issue because that my volume is there. Okay, and bind mount is not the volume data. So now what is my home directory is /home Ubuntu or maybe /home, easy to use, that depends upon the OS version. In that I want to store those uh, m- files like inside the image. But compared to bind mounts, security wise, performance wise, use the Docker volumes itself. Volumes data is managed by Docker. But other than that, if you want to give any other areas like other our own path in the Linux system, if you want to use, then we need to use the bind mount. Then we need to use the bind mount we need to use. Okay. So then like here we have one more TMPFS, but for the Windows and Mac it is not supporting. It's only supported for Linux only. But TMPFS is the it's going to store in the swap memory, it's going to store. Okay, or in the RAM it's going to store, but data is not at all when the containers stop, the data is going to be lost. Even if the system reboots also, we are losing the data. Okay, so these all the supported by Docker, but mostly when we are using the Docker, we are using the Docker volumes. But in that we can use the Docker volumes. Other than the Docker area, volumes area, our own custom paths we want to specify, then we need to use the bind mounts, or in the memory or swap memory if we want to store, then we need to use TMPFS, we need to use it. Okay, then here we have the command how to create a volume is, if you don't create a volume also, if you attach to the container with the option -v, or we can use --mount also. Okay, then automatically that container is getting created. Then volume ls will list all the volumes. Then inspect will describe more details regarding that volume. Then if you want to remove the volume, okay, volume or M. And like if you want to clean up all the unused volumes, then we need to use volume prune. Okay, volume prune we need to. Then here try to understand Docker run. Okay, hyphen D is a detach mode, hyphen name. Then hyphen E is environment variable. We are passing the password. Hyphen V, MySQL data. Whatever in the var lib MySQL, I'm going to store in the MySQL underscore data. Then assume I lost this container. Again, I can create a new container. And if I attach this volume, automatically all the data I'm going to get that. Okay, so that is also maybe for the backup of that container also we can use. Even if the container deleted also, we can use that volume we can use. Okay, and if you want to share the data also between the containers, I'm attaching the shared data is the volume name. In both the containers, I'm attaching the same volume. Then the both the containers are sharing the same data. Instead of creating 100 volumes, so I have my like a web apps folder, I have my var file. I want to keep that one in one location, and I'm attaching that to 100 servers also in the same path. I'm going to copy that. Okay, then here we can use the bind mount. So what is this meaning of dollar present working directory is from where I'm running this in that what is the working directory mostly like from our home Ubuntu like this it's going to take, and this is the container internal data. Both are getting mount kind of things. Okay, and even we can use hyphen TMP FS also. Okay, in the real time we don't use, but we required. Say, if we use hyphen V hyphen mount, that is one method, or we can use other than that volume type equal to bind we can give, or we can use TMP FS also we can specify. Okay, but always among the three, which is recommended method,
Volume.
volume itself is recommended for the security and performance wise also. For the security and performance wise, it's recommended to go for the volumes and don't use anonymous kind of thing by using directly hyphen V without having the name. Always maintain the good naming patterns, naming conventions also for the volumes, and plan for the proper backup also for the volumes. Okay, so then here we need to use all the documentation, which of the volumes we have used, all those also we need to manage. Okay, so these kind of best practices we need to follow. And what is the Docker Compose also we'll discuss. Then by default, if the container is like already created, we can't add or modify a volume to an already running container. Okay, if already that container is created, we can't add. Okay, so here what we can do is like here we are inspecting whatever that container details we have. Then we're attaching a volume to new container. We're attaching the new container we're attaching. Then what we are going to do is again with the same volume we're attaching another container. Okay, so that is the method, but directly we can't attach those, or we can copy the files also. Okay, so that means by default it's not possible to attach these to the running container, but we have some workarounds. That's like a we can add to that existing container or copy the files from one location or create a new container also with the same image with the Docker commit. Like that we can do. And networking also, say suppose whatever the containers we have created, we are going to expose outside, and that exposing how is going to work and how the communication is going to happen, we'll discuss. So now, like how the containers are communicating with the each other, and how the container is communicating with the host mission, and from the outside world, how the containers are communicating. So if you understand the Docker volumes, Docker Compose, Swarm, then Docker networking, Docker logs, inspect, then how to run the containers, commands inside the container. These all would be more useful for us in the Kubernetes wise. Okay, so whatever the knowledge we are getting on the Docker level is more useful for Kubernetes level. Okay, so now, so in this use case, we have that how the communication is going to happen. By default, okay, so we are getting a bridge network, we are getting, and we have the host and none. Okay, so that's we have the bridge. By default, we are getting the bridge. Okay, so what is the meaning of bridges? Like over the bridge network, and every container will get a private IP, but using the host mission IP, we are going to authenticate. Okay, but if I use the host, there is no isolation. Okay, and if I use the none, that container is maybe like an isolated, means from the host also we can't communicate, means it doesn't have any networking. Okay, so just I want to run that container. I don't want to access that. Then at that moment we are going to use none. If you don't specify anything, by default, all these days we use that Docker run command. Then it's going to use the bridge. It's going to use the bridge network. Okay, so that means default network also. If you don't specify any network, by default we are getting the bridge itself. In the bridge, those where every container will get a private IP, and using that host IP address and the port number, we can authenticate. We can authenticate with that. Okay. And additional to this, like Docker, by default, the bridge network, every container gets its own IP address, and on the same bridge we can connect with by using the container name. Okay, and the host also can be accessible through the port mapping. That 8080:80 means from the host IP 8080 we can access that container. Okay, so then even multiple containers also can connect, but the container shared the host IP address. Okay, but no natting. Uh, like here we are going to use the host. Okay, but it's going to listen directly on the host itself. But now if I use the bridge at the host level also, I may have a Nginx and I may attach 80 port to that. But inside the container, I'm attaching 8080. But now if I use the host port itself, it is going to use. And it's going to use the same IP as the host itself. Okay, from outside also we can access. None is even from the neither host or not that external, it's going to be accessible. From other containers also, it's not accessible. Only for the security kind of thing. I don't want to give the external access kind of things. Then we are going to use the host kind of method. Okay. So then in the Docker Swarm environment, say suppose we discuss the complete like a clustered kind of environment, or we can have the like group of servers as the clusters. At that moment, it's going to use Docker Swarm. In the Docker engine environment, what is the default network we are getting? The Docker Swarm environment, we are getting overlay. But in the normal environment, we are getting
Which
in the bridge we are getting. But in the overlay, we are getting sorry, in the Swarm environment we are getting overlay, and in the overlay we have the multiple Docker engines, all can communicate. all can communicate with each other across the multiple Docker hosts. It's communicates. In the Kubernetes also have Kubernetes networks we have. Those on the Kubernetes is very powerful networks. Those we'll discuss.
Yeah.
Okay. Then one more method is there, one more network driver is that's called as MAC VLAN. So what is the concept of MAC VLAN is by default every container won't get a MAC ID, but going forward for the security purpose, for auditing purpose, just like your mobiles will have the IMEI number, right? In the same way, every computer or laptop, even a virtual machine in AWS EC2 instance, Azure VM, everything is getting a unique MAC ID. It's a physical address kind of thing. Okay, but for the containers, by default, we are not getting the MAC, but here we can assign a MAC address also to the container. Okay, so where mostly like we need to auditing kind of thing, and we want to isolate even at the container level also we want to isolate and we want to audit that who perform those operations. At that moment, we need to use MAC VLAN. Okay, so then we need to use -d Mac VLAN, and even we can use like a custom plugins also. Even in the Kubernetes also we have Vue, Calico, Flannel. These are the other companies also providing some their own network drivers also. Okay, so now if someone asks about networking, how the containers are communicating, all those we are getting through like networking options. Now by default we have the bridge network, then host, then none, overlay, then we have Mac VLAN, then even we have a IPv LAN also we have. Say IPv4, IPv6 both we want to control, then even we can use IPv LAN also we can use. These are all the different type of network drivers we have.
Sir, I have doubts.
Yeah, yeah.
Host means is it a server or a cluster?
No, no, host is also is a Docker Docker daemon itself, not a cluster.
Okay.
Directly, say suppose here I'll tell one example. If I use the bridge, okay, so every container again getting an individual IP address, we are post forwarding from host to that container. Means say suppose in the Docker run, if I use -d -p, then host IP I'm using with the 8080 that is forwarding to 80 port. That is forwarding to
IT port
80 port. Inside that container level, it's forwarding to
8080.
yeah, 8080, it is forwarding. If it is a host port, automatically on that mission itself, that 80 port is assigned. In this bridge scenario, on the local mission also, you may have Nginx that's maybe using the default 80 port.
Yes, sir.
Okay.
Okay, sir.
So here we have in the SWAM environment, what is the network we are getting?
Overlay.
Overlay. And
But
Mac VLAN.
the functionality of this bridge host and none is to expose the containers, sir.
In the none, it's not exposing.
Of course, but the purpose is
Yeah, purpose is how the containers are communicating with each
getting
other
with
like
each.
that.
But
Okay.
this MACLAN is different from those three things.
MacVLAN is mostly after some days, in the next 1 to 2 years, mostly MacVLAN also by default it may become default one.
Okay. So
Because
combined it will work.
assume I'll tell one example. Say suppose here I have one host, in that I have 10 containers. Okay, some fraud operation happened, but we can't identify from which container it got.
Yes, sir.
But that host we can identify. But
So
if we
suppose
have,
that there needs to be, we need to do auditing, so we keep it
yes,
as
yes,
math lab.
yes,
And
yes.
also they has to communicate with each other. That also we need to
That is
keep a
not required a
picture.
MAC ID. That IP address is there.
So a container can have multiple network types.
Yes, yes.
Okay, sir.
Even custom also we are getting now Calico, those also providing the drivers. So it depends upon the drivers that behavior comes.
Okay, sir.
Okay. So then
IPv LAN means public IP or private?
IPv4, no, private only. IPv4, IPv6 also we want to maintain, then we are using IPv LAN. So some specific requirements, I want pure IPv6 kind of environments, then we are going to use it.
Okay, sir.
So all these we don't use because everything we'll use in the Kubernetes only. But we require good knowledge in this. Okay. So then uh, with the volume, what is the one advantage is if at the time of creation, if you don't have a volume, it will create a volume, but network is not like that. Okay. And one more very important is there, a bridge. By default, we are getting the bridge. Okay. And that bridge also is given installed by Docker itself. But we can create our own custom bridge drivers we can install by own also. So here how to create our own bridge also we'll discuss. So now here if I use like a Docker network create a like this is a what is this mynet? Mynet is my
Con-
bridge custom bridge network.
Okay.
By default we are getting one bridge network, but this is my custom bridge network. Then while creating the container to this network I'm attaching. Okay, that means by default, even if you don't use any network also, it goes to bridge only. But in this, what happening here? Is it going to bridge or custom bridge in this command?
Custom bridge.
Yeah, what is that custom bridge name?
Mine it.
Mynet. Okay, so now try to understand. We have two containers, and I want the communication between those two containers. Then, like very long back, we need to link those containers, but both the containers now are running in an isolated environment. We don't get the communication. But what is the use case today for me? What is the
Able
use
to it.
case? I want to connect those two containers. Say suppose assume I have one like one application on Tomcat I have, and this I want to communicate with MySQL. MySQL is another container. I want to communicate both of them. At that moment, what is going to happen is I need to create both of them by using the same custom bridge network. Then the communication is going to happen between them. Then two containers are running in an isolated environment by default. If they want to communicate with each other, the modern approach is
Using custom bridge.
using the custom bridge, bring them into same bridge. Same bridge network we can use, then both can be connected. And what
Each
is this command? So here already my container is there. That is in the default bridge, but I don't want that with the default bridge. Then what is the command here? Docker network connect to Docker network connect, and mynet is my network name, then my container is already running container. And if you want to remove that, then disconnect. And if you want to remove the network, rm mynet. Okay, even we can use the prune also. Okay, so now here if you use this localhost colon 8080 or that IP address 8080, but it's internally forwarding to 80 itself. If I use the host, directly that we don't need to attach any port. Host wise, whatever the port we have, that itself is going to be attached to that. Okay. So if I use hyphen network is none, then it's not going to be communicated. So always don't use the default bridge also. Better to use a custom bridge. Okay. And use the container names instead of IPs. Then we can use like a multiple host for overlay. And if you want the MAC ID, physical address auditing, better to use MAC VLAN. And I don't want to expose that itself that need to run in an isolated environment. Then we need to use the none option. And IPVLAN also we have. So now here Docker network LS. So by default we are getting a bridge, host null. In the SWAM by default we'll get
Overlay.
overlay. In the Docker host environment, we don't get the overlay. And we can, even here, if we don't specify hyphen driver, what we have specified here, hyphen driver, what I have specified, bridge. If I don't specify as the bridge also, what is going to happen is,
Default widget
the
trees.
default itself, it will create a bridge. It's a custom bridge itself, but driver is using default as a bridge itself. Okay.
Means containers in default bridge cannot communicate with containers with custom bridge.
No, it won't communicate. So
Okay.
that kind of security we need to provide to that.
Okay.
So all backend applications want to communicate with each other. Front-end applications want to communicate with each other. Like this, we want to isolate them. Then better to use the custom bridge networks.
Okay, sir.
The connect and disconnect is there. For the existing container, we want to attach a new network. Then we are using connect. Already network is connected. I want to disconnect that. And RM prune will remove that. And that pinging also will discuss. Port mappings, Docker port, that container name, like even in the Docker PS also it shows. Otherwise, you want explicitly that Docker port we can use. Docker port we can use. And Docker volume, already we discussed this. Always use name volumes, don't use anonymous. And separate data always at the host level also. Again, we need to take the backup of that data also for the production. And while attaching the volumes, one method is -v, one method is -mount. Docker is recommended to use the -mount option compared to -v. Okay, always better to use the -mount option. And obviously we need to take the volumes backup also. And don't keep the sensitive details in the volumes. And networking wise, always prefer to use custom user-defined bridge networks. Okay, then networking names, good naming conventions we need to use and isolate those services with the multiple custom networks. And not recommended to directly use the host network, unnecessarily port conflicts will come. Okay, so that's not a best practice. Use the bridge itself. And obviously we need to use overlay. Okay, so then only expose that. Here we have a hyphen p is there, and even we have a capital P. So they all these days we use the small p itself. There is a slight difference between while publishing the ports to small p and capital P. So what are those differences also we'll discuss. But always is secure to use small p only. That means which of the port is required only that is exposed. If I use the capital P, okay, all ports are getting exposed. That's security wise not a best practice. Okay, if I use the small p, only that port, I know the exact internal port. Okay, even that instruction we are getting from the Docker file. Okay, if you don't know that port, what we need to use is capital P I need to use. But security wise, it's risky. Okay, so here network level, we have the network inspect, and we can go inside and we can ping. Okay, so here what is the DNS based service discovery also will discuss with the user networks. We don't need to use the like hard coded IPs also. So volumes networking, if you understand at the Docker level, then only we can understand the Kubernetes communication. Okay, so till this like whatever we have discussed, try to finish those videos. So till whatever I have shared yesterday, try to finish. Okay, and for tomorrow, before tomorrow session also, I'll share some more videos also. Docker file I'll share. That is very important from the interview wise, even from the job wise also. Try to finish those videos. Okay.